Hold on to your hats, space fans. Earth has a new celestial dance partner, well, at least for a little while. A small asteroid dubbed 2024 HO3 has been spotted hanging around our planet. Get this, it's going to stick around for a couple of months acting like a mini-moon. How cool is that? We're used to our trusty old moon, but having another one, even temporarily, is pretty darn exciting. It's like having a house guest from outer space. This gives us a fantastic opportunity to learn more about asteroids in our solar system. So, what exactly is 2024 HO3, and where did it come from? Buckle up as we blast off on an exploration of this fascinating cosmic visitor. Let's meet our new mini-moon 2024 HO3. Picture a giant space rock somewhere between 40 and 100 meters wide. That's about the size of a football field. Now imagine this rock tumbling through space, minding its own business, when suddenly, whoosh, Earth's gravity grabs hold. Don't worry, 2024 HO3 isn't going to crash into us. It's caught in a delicate gravitational dance with our planet. This dance will last for about 2 months, during which 2024 HO3 will be our cosmic companion. This isn't the first time an asteroid has been caught in Earth's gravitational pull, and it won't be the last. Our planet is like a cosmic magnet, attracting all sorts of space debris. Most of it burns up in our atmosphere, creating those beautiful shooting stars we wish on. But sometimes, just sometimes, something a little bigger gets caught in our orbit. So, how did 2024 HO3 end up as our temporary moon? It's a fascinating story that involves the intricate dance of celestial bodies and the invisible forces that govern their movements. It's all about gravity, baby. Gravity is the force that keeps us grounded on Earth, but it also plays a crucial role in the movements of objects in space. Without gravity, the universe would be a chaotic mess of drifting matter. It's like a cosmic game of cat and mouse between Earth and the Sun. The Sun, being the massive star at the center of our solar system, exerts a powerful gravitational pull on everything around it, including Earth and all the other planets. Imagine the Sun as a giant disco ball, its gravity pulling everything towards it. This gravitational pull is what keeps the planets in their orbits, preventing them from drifting off into the void of space. Now picture Earth as a smaller disco ball, also exerting its own gravitational pull. While the Sun's gravity keeps Earth in orbit, Earth's gravity influences objects that come close to it, like our moon and occasionally asteroids. Asteroids like 2024 HO3 are like tiny glitter balls caught in the middle of this cosmic dance floor. These asteroids are remnants from the early solar system, and they move through space, sometimes coming close to planets like Earth. Sometimes these little glitter balls get nudged a little too close to Earth. This can happen due to various factors such as gravitational interactions with other celestial bodies or even collisions with other asteroids. When that happens, Earth's gravity can overpower the Sun's pull, at least for a little while. This is a rare occurrence, but when it does happen, the asteroid can become temporarily trapped in Earth's gravitational field. That's what happened with our friend 2024 HO3. This asteroid found itself in the right place at the right time, and Earth's gravity managed to capture it, making it a temporary moon. It got too close, Earth's gravity gave it a tug, and bam! Temporary moon status achieved. But this status is not permanent. The forces at play are constantly changing, and the delicate balance can be disrupted. But here's the thing, this gravitational dance is a delicate balancing act. The gravitational forces from both the Sun and Earth are constantly influencing the asteroid, and even a small change can alter its trajectory. Eventually, the Sun's gravity will win out, and 2024 HO3 will be flung back out into the depths of space. This is because the Sun's gravitational pull is much stronger than Earth's, and over time it will pull the asteroid away. It's all part of the grand cosmic ballet. The movements of celestial bodies are governed by the laws of physics, and while we can predict their paths, there's always an element of unpredictability. The story of 2024 HO3 is a reminder of the dynamic and ever-changing nature of our universe. Section 4. A wobbly dance, understanding temporary orbits. Okay, so 2024 HO3 is stuck in a temporary orbit around Earth. This means that the asteroid is not permanently bound to our planet, but for now it is caught in a delicate dance with Earth. But what does that actually mean? How does an asteroid get caught in such a temporary orbit, and what keeps it there? Imagine you're spinning around on an office chair with a basketball in your hand. You feel the forces acting on you as you spin, and the basketball is influenced by these forces too. You toss the basketball up, and it circles around you a few times before falling back down. This is a simple analogy to help us understand the complex gravitational interactions at play. That's kind of what's happening with 2024 HO3, but on a much larger scale. The asteroid is caught in a gravitational dance with Earth influenced by the forces of both our planet and the Sun. The asteroid isn't orbiting Earth in a perfect circle like our moon does. Instead, it follows a more complex path. Instead, it's following a wobbly, elliptical path. This means that its distance from Earth changes as it moves along its orbit. It's like Earth is spinning a hula hoop around its waist, and 2024 HO3 is a bead sliding back and forth along the hoop. The bead doesn't stay in one place. It moves in response to the forces acting on it. This wobbly path is caused by the competing gravitational forces of the Sun and Earth. The Sun's gravity tries to pull the asteroid away, while Earth's gravity tries to keep it close. It's like a cosmic tug-of-war, with 2024 HO3 caught in the middle. The asteroid is constantly being pulled in different directions, creating its unique orbit. Sometimes Earth pulls a little harder, sometimes the Sun does. And this constant push and pull creates that funky orbit. The result is a temporary wobbly orbit that can change over time as the forces acting on the asteroid shift. Over time, the orbit of 2024 HO3 can change. It might get closer to Earth or drift further away, depending on the gravitational influences it experiences. There are other asteroids with similar temporary orbits around Earth. Each one has its own unique path, influenced by the same cosmic forces. Understanding these temporary orbits helps astronomers learn more about the dynamics of our solar system. It provides insights into how objects move and interact in space. By studying the orbits of asteroids like 2024 HO3, scientists can predict their future paths and assess any potential risks they might pose to Earth. This knowledge is crucial for planning potential asteroid deflection missions, ensuring that we can protect our planet from any potential threats. So, while 2024 HO3's temporary orbit might seem like a small detail in the vastness of space, it plays a significant role in our understanding of the cosmos and our place within it. The dance of 2024 HO3 around Earth is a reminder of the intricate and ever-changing nature of our solar system. It's a fascinating glimpse into the dynamic forces that shape our universe. And that concludes our exploration of temporary orbits. Stay tuned for more cosmic wonders in our next chapter. Section 5: Astronomers Buzzing, a rare glimpse up close. You better believe astronomers are geeking out over 2024 HO3, and for good reason. Having an asteroid this close gives us a golden opportunity to study these space rocks in detail. It's like having a front row seat to the solar system's greatest show. Astronomers are already training their telescopes on 2024 HO3, eager to learn everything they can. They want to know what it's made of, how fast it's spinning, and what its surface looks like. This information can help us understand how asteroids form and evolve over time. Think of it like this: if we want to understand the building blocks of a cake, we need to study its ingredients, right? It's the same with asteroids. They're like the leftover ingredients from the formation of our solar system. By studying them, we can learn more about how our cosmic neighborhood came to be. Section 6: Planetary Defense Learning from Our Rocky Neighbors. Here's a sobering thought. What if 2024 HO3 wasn't a harmless mini-moon, but a giant space rock headed straight for Earth? It sounds like something out of a Hollywood blockbuster, right? Imagine the chaos and destruction that could ensue if such an event were to happen. The idea of an asteroid impact might seem far-fetched, but it's a real and present danger that scientists around the world are working tirelessly to mitigate. The threat of asteroid impacts is a real concern, and it's not just science fiction. Throughout Earth's history, our planet has been bombarded by space debris, some of which have caused significant changes to our environment and even mass extinctions. The dinosaurs, for example, were wiped out by a massive asteroid impact around 66 million years ago. Studying objects like 2024 HO3 is crucial for protecting our planet. By observing 2024 HO3's orbit, size, and composition, scientists can refine their models of asteroid behavior. This small rocky body, which orbits the Earth in a quasi-satellite manner, provides a unique opportunity to understand the dynamics of near-Earth objects. By analyzing its size and composition, researchers can gather valuable data that helps them predict how similar objects might behave. This information is essential for developing accurate models that can forecast the paths of potentially hazardous asteroids. Understanding the physical properties of these space rocks allows scientists to devise effective strategies for dealing with them. This information can help us predict the paths of potentially hazardous asteroids and develop strategies to deflect them if necessary. It's like learning to play cosmic billiards, using gravity and physics to nudge dangerous space rocks out of our way. The more we know about these objects, the better prepared we can be to protect our planet. Developing strategies to deflect asteroids is a complex and challenging task. It involves understanding the intricate dance of celestial mechanics and using that knowledge to alter the trajectory of a potentially dangerous object. Techniques such as gravity assists, where a spacecraft uses the gravitational pull of a planet to change its course, are being explored as potential methods for asteroid deflection. It's like playing a high-stakes game of billiards on a cosmic scale. By carefully calculating the forces at play, scientists can use gravity and physics to nudge dangerous space rocks out of our way. This requires precise measurements and a deep understanding of the behavior of these objects. 2024, HO3 might be a temporary visitor, but it offers a valuable opportunity to test our planetary defense systems. By studying its orbit and behavior, we can refine our techniques and ensure that we're prepared for any future threats. This small asteroid serves as a natural laboratory for testing our ability to detect, track, and potentially deflect hazardous objects. Testing our planetary defense systems is crucial for ensuring that we're ready to respond to any potential threats. This involves not only developing new technologies but also conducting simulations and drills to practice our response strategies. By being proactive, we can minimize the risk of an asteroid impact and protect our planet from potential devastation. It's all about being proactive, not reactive. By studying objects like 2024 HO3 and developing effective planetary defense strategies, we can ensure that we're prepared for whatever space throws our way. The more we learn from our rocky neighbors, the better equipped we'll be to safeguard our planet and its inhabitants.